All right, today I want to just talk through one of these calorimetry problems where you have to solve for the final temperature of the system. These are challenging because there's going to be a variable on both sides of the equation. So when I'm reading my problem, I like to underline the things that I know. So I have 440 grams of mercury. I have its specific heat. The initial temperature is 22 degrees, and we're going to place that into some water that is hot. We know its specific heat and its initial temperature, and we're trying to solve for the final temperature of the system. Notice that the water is at a higher temperature than the metal. So that means that the water is going to be giving off heat and the metal is going to be absorbing it. So when we're thinking about our water is going to have a negative Q value because it is going to be giving off heat. And then our metal will have a positive Q because it will be absorbing the heat from that water. Remember, Q is equal to Cm delta T. Since our Q's up here are equal, they just have opposite, plus and minus. We can actually set their Cm delta T equal to each other since the Q is equal. Okay, so it will look like this. We have our metal that's gaining heat, and then our water, which is losing heat. So the left side will be a positive Cm delta T, and the right side is a negative overall Cm delta T. So then you're just going to plug in the things that you know from the problem. So we know the specific heat of mercury, which was 0.14 joules per gram degree Celsius. The mass of that mercury was 440 grams. And the delta T is T final minus the initial temperature of that metal, which was 22 degrees Celsius. On the right side, again, we know the specific heat of water. It's 4.184 joules per gram degree Celsius. The mass was 134 grams. And for this one, the T final minus T initial is T final minus 35 degrees Celsius. So I'm just going to plug those values in. Notice I have a TF variable on each side. So at this point, I'd like to kind of rationalize the problem a little bit. So I'm going to multiply those numbers that are in the front here. And then we will distribute that through times our TF and times our negative 22 degrees Celsius. On the right, we will have a negative number when we multiply these two. And that negative number will then multiply through our TF and then our negative 35 degrees Celsius. Remember, this negative times a negative will give you a positive number. So that is one place where people typically go wrong when they make mistakes with these. So first, I'll just multiply those first two numbers on each side. So I multiplied this number by this number and got 61.6. Then I did 4.184 times 134 and got my 560. Notice that those units really travel through the problem. My grams canceled out here, so I have joules per degree Celsius. And then on the right side, again, my grams canceled out, and I just had joules per degree Celsius. Okay, at this point, we will take this number, 61.6 on the left, and multiply it through times the TF, and then times the negative 22 degrees Celsius. On the right side, we have negative 560 TF, and then negative 560 times negative 35, which gives me a positive value. Okay, then you want to combine like terms. We want to get our TFs together on one side. Then we want to get our numbers together on one side. And preferably, if they could be positive, that would be great because then we don't have to deal with negative numbers. So I'm going to put my TF on the left and I'm going to put my numbers on the right. We get 621.72 TF is equal to 20,959 degrees Celsius. Then we will divide both sides by 621.72. And then we get a final answer of 33.71 degrees Celsius.